Autonomous agents need more than smart execution. They need safe exits. In this section, we'll look at how risk triggers escalation, how operators intervene in real time, and how recovery plans restore control when behavior goes off track. Up to this point, we've built the security foundation, understanding autonomy risk, constraining tools, validating inputs, sandboxing, and defending against prompt injection and data leakage. We also defined when approvals are needed and how gates should work. Now we shift to execution, how humans stop, redirect, override, or roll back agents as conditions change. A pre-approval gate answers one question. Is the plan acceptable before the agent starts? That matters, but it is not enough. During execution, the agent may receive a strange tool result, face unclear instructions, hit a policy conflict, or encounter malicious content. Risk changes as context changes. Escalation and intervention give humans a way to step in at that moment, to interrupt an action, redirect the workflow, investigate what happened, or recover safely. The goal is not to slow agents down. It is to limit blast radius when conditions shift. Escalation is not just an alert. It is a routing system for risk. When an agent hits an elevated condition, the first questions are, what kind of risk is this? How severe is it? What business impact does it create? And who has authority to decide? A security issue should not follow the same path as a privacy concern or a financial exception. Strong escalation also defines response time, decision rights, and fallback behavior. Without that structure, delays and confusion can leave the agent operating with too much autonomy. The escalation path should match the risk. A suspected intrusion needs security operations or incident response, not a business manager. A workflow decision that affects customers belongs with the product owner or process owner. PI exposure, regulatory uncertainty, or contract risk should pause the agent and involve privacy, legal, or compliance review. Changes that could damage systems or data integrity need system owners, platform engineers, or database administrators. This prevents two common failures: over-escalating everything to one queue and sending urgent decisions to people without the authority or context to act. Severity keeps governance from becoming either too noisy or too slow. A low-risk anomaly can be recorded or checked with the user without interrupting the agent. A medium event deserves operator review because the agent may be entering uncertain territory. High severity means the risk is no longer routine, so execution should pause until a qualified approver decides what happens next. Critical events are different again. They call for containment first, then incident response. The key is matching the response to impact, so humans intervene where judgment truly matters. To work reliably, escalation should behave like code, not like a vague instruction to notify someone. When a risk event appears, the agent classifies it using factors such as risk score, tool sensitivity, data class, transaction value, and violation type. That classification determines the approver path. While the agent waits, its behavior must also be defined. Pause, continue only safe read-only work, ask for clarification, or cancel. If no response arrives before the timeout, a fallback route takes over and a safe default applies. Reviewers get enough context to decide without unnecessary sensitive exposure. Human intervention controls are not interchangeable. Stop is the emergency brake. It terminates the agent session when risk is critical, a policy is violated, or continued execution is unacceptable. Pause is a holding pattern. It suspends work, preserves context, and gives a reviewer time to clarify, approve, or redirect. Cancel is narrower. It blocks one pending action, such as a risky tool call, while allowing the overall conversation or workflow to continue. These controls need clear permissions, auditability, and high visibility, so authorized operators can act before uncertainty becomes harm. An emergency stop is the last line of runtime control. When triggered, it should cut off dangerous tool calls, cancel queued work, pause autonomous loops, and block further system changes. The default should be fail-safe. If the agent's state is unclear, stop first and investigate. Because this control is powerful, it also needs strong access control, tamper-resistant logs, and protection against casual or malicious use. Activation should notify responders immediately, start triage, and require a documented review before any restart. Intervention should not become a vague, "are you sure?" moment. Confirmation is for validating user intent before meaningful or external action, especially when instructions are ambiguous. The prompt should name the action, target, data involved, and likely consequence, so the user confirms an informed decision. Administrative override is different. It is a privileged exception path, used only by authorized roles in defined scenarios. Because it bypasses normal decisions or approval gates, it needs stronger controls. Every override should capture who acted, what changed, when it happened, why it was justified, and the resulting system state. Overrides are necessary because real systems hit edge cases, but they should feel like controlled exceptions, not secret backdoors. Start by deciding what can ever be overridden and what remains a hard stop, especially for safety-critical controls. Every override needs a reason, an approver, a narrow scope, a clear time limit, and the exact resources affected. For high-risk cases, require 2 authorized reviewers, so one person cannot weaken protection alone. Finally, make temporary access expire automatically. Log the decision and recheck the policy when the exception window closes. When agents can change real systems, safety depends on more than preventing mistakes. We also need a way back. For high-impact actions, prefer workflows that can be reversed before damage spreads. Before destructive changes, capture backups, snapshots, version history, and transaction logs, so recovery has evidence to work from. Some actions cannot be perfectly undone, like sending a message or moving money, so design compensating actions that repair the outcome. And do not treat recovery as theory. Test it, document it, and connect it to approvals and escalation. Reversibility starts by treating every agent action as a proposed change, not an immediate commitment. The workflow moves from draft to validation to human approval, then apply and verify. At each step, the system can pause, cancel, or roll back before damage spreads. The key is preserving state. Record what existed before, what changed after, and what safe state should look like. Prefer idempotent operations, so retrying does not compound harm. This pattern turns intervention from a risky one-way action into a controlled, reviewable, recoverable process. Controls are only useful when people know exactly how to use them. A good intervention playbook turns a vague alarm into a practiced sequence. Detect the issue, pause the agent, bring in the right owners, choose a response, and roll back safely. For example, if an agent tries to email a sensitive customer report outside the company, the team should know who can cancel the action, who reviews logs, who approves notification, and how recovery is verified. Readiness is measured with operational metrics: time to pause, escalation speed, approval latency, and rollback success. Clear ownership prevents panic. The core lesson is that approval should not be a one-time gate. As agent risk changes, escalation routes bring in the right authority, intervention controls, let teams stop, pause, confirm, cancel, or override actions, and recovery plans restore a safe state. Next, we connect these safeguards to observability, audit trails, and incident readiness.